Welcome everyone to a new session from Tool Design Drawing. Today we are going to discuss about uh, the new topic, advanced multi-stage tooling. The context for designing a progressive tool for a particular part arises when the part needs to be produced efficiently to meet the time constraints to delivery. Progressive tool undoubtedly overwhelms the efficiency in terms of time consumption to produce the same part using the other type of method, which is the unit tooling setup. Because the teardown time is a big drain of time when it comes to the different setups that need to be arranged to complete the different operations on the part using the unit tool method. However, for all its advantages in terms of time taken to produce a part using unit tools, progressive tool has its challenges in developing and tool building. The chapter we are going to discuss will give you an exposure to some of those challenges in developing a progressive tool, especially when there are multiple operations involved. So let us discuss the um, one of the samples from multiple stage tooling. So we need to have a specimen to take this discussion forward. So let me share the screen here. Okay. Okay, so this is about the advanced multi-stage tooling. This is one of the is the last chapter of the sixth semester of the tool engineering and digital manufacturing program in tool design drawing. So look at the specimen which is on the screen. Uh, it's a part which is made out of CRCA, cold rolled, cold annealed, and look at the features. It's having a hook-like profile. Um, it's having a hook-like profile and a slot punched on the sides, on both the flanges, and uh, there are two holes, reference holes. So this is how it looks like. And let us look at the dimension requirements. Here we see a part. The profile here is just for the reference dimensions here, but you need to concentrate here where it is tolerated precisely. See, look at the form tolerance here, look at the positional tolerance, and you will have a closer look from the zoomed view. This profile here is tolerated to 0.25 quarter of a millimeter to A, B, C. And before we get into the numbers, we need to understand the three references, the three datums. Datum A is the plane which is just below the top surface here. So if you take the look at the isometric view or the 3D view, the surface here um, is termed as the datum. Okay, so the surface here, this surface here, this surface here is the datum A, the datum A, and 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 datum B is the diameter 12.5 millimeter hole here. So that would be this. This is datum B, and the third datum, of course, is the hole diameter 10 hole here. That is datum C. So these are the three datums on which the numbers are tolerated from. So what you need to understand is, like, take a look at this particular number here. It's tolerated to 0.15 millimeter with respect to A, B, and C datum. It's pretty close. And on the other direction, again, it is tolerated tight, 0.15 to A, B, and C. And the profile here is to be maintained to 0.25, again to ABC dimensions. So these are the rough relation between A and B. So what you need to understand is, this is tolerated very closely. These are close numbers. And how would you go ahead on the design part? As a beginner, like, you would think in the direction which you are seeing, watching on the screen. Uh, the normal tendency is to punch the holes here. All those holes, the datum A and B, B and C, datum B and C here, and you advance. Maybe you will pilot these holes and punch the holes, punch the slot, and then advance. Then you advance further. Then you cut uh, the the profiles, here, and you feed forward and then bend it here. So you'll get the shape, and finally you just cut it out. You got the part. This is, as a beginner, is a rookie design, I would say. But are we going to achieve the requirements is the question. Of course not, because this is where you need experience. So this would be a beginner's design. Definitely it is not going to give us the or the part is not going to be maintained to the numbers which is been demanded in the drawing. So what happens is, if you choose to do this way, this is what you just saw. You punch the holes here in the beginning, you punch these holes, and then you advance, pilot, and then cut these two holes. When it is flat, again you advance further, you cut open the profiles here, and then finally you will bend the part at this point. You bend the part and you get the U shape. So you might assume that these holes have, which was cut when it was flat, has come down to the right numbers what is required in the drawing. But it's a extremely difficult thing to maintain if you try to do it in this method, because it's not going to end up where you want. Uh, so then how would you go ahead with it? See, the point is, if this is to be maintained to a closer number, if this profile is to be maintained to a closer number, this is the final, what you see here in red is the final profile with respect to the A, B, and C datums. If this is to be maintained to the right numbers, what is needed, then better you should not attempt to finish it when it is flat. So that is what you will observe here. I take the pen, I would use a different color. I use blue. Okay. So what you need to do is, see, you need to keep some elements. Don't finish it when it is flat. Leave some materials, leave some meat here, so that this can be So this portion can be finished after it is bent to shape. Clear? And same way, don't attempt to finish the slot when it is flat. Never. Wait until the piece is bent to its shape and then you punch the hole to where you need. See? So, two things. Don't finish the profile. Keep some material. Keep some meat here so that you can cut it out later after it is bent. And never try to. So that means I will try to erase this. So don't do that. Don't do that. And try to keep some material here and wait until the part is bent to shape. So this is how we will go. We have to go it, right? You pierce the hole, file it. I mean, you're not cutting the slots here. Forward it, then you cut the um, you get the shapes, the profiles. So you feed it forward, you cut the profiles. Again, you feed it forward, and you bend it here. Bend you so you will get the U shape. In this direction, in this station, you will get the U shape. And then again you feed forward, then you cut the holes and trim the profile after it is bent, and finally you just cut out here and you got the part. So this is how you need to go ahead on this design. So now let us see the challenges now. So we already figured out we are not going to trim the profile as well as cut the eye slot when it is flat. So once it is shaped to the right size, we are going to punch holes and trim the line and maintain it to the right dimensions. So what normally, this is what you are going to do. I'll just see. So when the piece is bent to U shape, you pile it here, right? So you pile it here, and the stripper will hold it from the top and cut from this side, cut from this side. Now, what is going to happen if you do, if you intend, if you attempt to cut the slots in the same station? That is what we need to analyze. Take a look here. Now the cam has punched the hole from this side, and this cam on the left has punched the hole from the other side. Now this has punched and this has punched, right? So what has happened? You are going to get a slug here, right? So the slug will fall inside the line, right? Inside. Now it has to drop down, right? Now it has to drop down. But what is going to happen here is, this is basically just barely 30 millimeter width. So if you look at the basic numbers in the part, this is barely 30 millimeter. See, this gap here is barely 30 millimeter. So what happens here is, so I'll just try to draw it here. The slug which is coming inside when it is cut, and the cam cuts this piece, this is going to pile up here because there are no much gap here. Definitely it's going to pile up because there are 2-3 millimeter thick parts coming from, slug coming from both sides. Also, it will be drenched in coolant for better cutting. Sometimes it will be even magnetic. So finally you will have big pile of chunk here. And what is going to happen is, look at the horn. So what is going to happen is, you will have a big clog here. It will keep on piling. It may not fall through the slug hole. So finally, at one point of time, the die is going to burst. So you can't think of doing the cutting of these holes from of the both flanges in the same station. No. So the answer is no. So what you need to do is do one at a time. Cut from this side first. Don't do it from this side. Then you advance it forward and then cut from the opposite side. So here, in this way, when the slug falls in, there is at least some room here. So it can easily fall down and there is no slug thrown against the slug which is cut open into inside from the other side, right? So this is how you need to take this forward. Now we'll analyze what is going to happen in this method. Let us see. Now the piece is getting punched from one side, right? A component is here, it is getting punched from one side. So this is pretty slender. This is just 30 millimeter. We already discussed about it. So what is going to happen here is there is no support from this side at all. No? It's open. It's open area. It's open area. So what is going to happen is it will have a side thrust, and finally the screw which is holding the horn will break, right? The whole the screw that is holding the horn will break. So this is not a good condition at all. It's not a good condition at all. So you need to make it work successfully. We need to think of something else. So an option left to us is support from this side before the hole is punched from the opposite side. See, if you arrange a support from the opposite side before it, and it should be before the part is getting punched from the other side, okay, not simultaneously. This is how we have to go ahead. So now this will be the setup. Where is that? Now you need a driver. See, the driver will come down, and it will push on the supplementing angle here. So the cam will move forward, and this again will come down. Again, this supplementing angles will get engaged, and it will get pushed forward, and this will support here. But observe it closely. These two are in the same line, right? When it is going to come down, it will engage both cams at the same time. It will engage it simultaneously. But this is, let us analyze what is going to happen then. See, keep an eye over here. It is operating simultaneously. See. So what is going to happen is this will come here, and by the time this would have already started to punch the hole. So basically you will miss the objective. What you wanted is you want something to hold it, this is what you want, right? Something to hold the part or the horn from the opposite side before the punching takes place. Before the punching takes place. This is the condition you intend to. So you can't have the same length drivers uh, doing the job simultaneously, because that will kill the objective. So how we will adjust the timing. So the cam, support cam can be called as the bypass cam, right? Now what you need to achieve is the cam should come and just support the back of the opposite flange before the punching takes place from the opposite side. So the best way to do is make the driver of the bypass cam longer than the trim cam driver. See, this is short. See, this is short here, right? So this is longer. So when it comes down, it is going to engage on the bypass cam and it will push it forward. So this will reach first. This is going to reach here before this can even get closer. And this is the condition which you need. But the question again is, if this is going to come forward, then it will keep on moving forward and it might put some thrust here on the other direction, over thrust. So, but it's not going to happen. Just take a look at the other next picture. When it comes down and once this angle passes the supplementing angle on the bypass cam, the straight portion is going to get engaged, no? And the first movement is straight down. This cannot exert any more movement because it is straight. It will just rub on the back of the tail of the bypass cam and it will just cycle back. That's it. And by the time the cam has already come and but it has already come and supported the part, and see, the punch has not reached near the flange. This is the condition which you intend to. See, it has again come down. No movements here. It is staying where it is because it's a straight portion which is rubbing, and here now it has started to cut. And it is now both drivers are shaded for better comprehension, and this in the bottommost condition, this is how the part will be processed in that particular station. So this is a key point here, and now the driver is going to bring the push the cam forward and initiate the cut, and somebody has to take this cam back once the driver goes up, right? So you can observe here there is a gas spring, gas spring here, and this gas spring is going to push the slide back into position, and it's on either side too. So this is how the strip layout will look like. You, as usual, you just cut the piercing holes and maybe you cut a notch, and you just file it, and you, as I said, no more piercing of the eye slot, and keep extra material just to be shaved later. So you do the cutting here, cut the shape here, advance it forward, and you bend it. It has to be done simultaneously. You will get the U shape in this particular station, and you feed it forward. Take a look at the next the stage wise depiction. So you bend it here, so you do the cutting, you bend it here, you leave an idle station for the tooling purpose, then use the bypass cam from this side, right? So you support it from this side, and I would choose a different color for cutting here. So you cut it from this side, so pierce and trim from this side. Now take it forward, and again it's an idle stage here, take it forward. The bypass cam will be supporting the already cut flange in this stage, and the pierce cam, which is on the will operate from the opposite side and finish the cutting on the slot and the trim line from the opposite side. And finally you just do the cutoff and you get the part. So this is how you need to address the situation, especially when it is the numbers are very tightly tolerated after bending. So it's another isometric view of the thing. So you are feeding it in this direction. You see all the holes punched in the beginning and the notch, and here you do the cutting. Here you do the cutting here, and make sure you are leaving some stock here, some material, some kind of meat, so that it can be shaved in a later stage. And in this position, you are going to bend it. So you're getting the U shape in here, and again feed it forward. So again feed it forward. So that is what you see here. Use a bypass cam, hold it from the back side, and cut from this side. So you cut um, the slot as well as this profile line. So take a good look at the opposite side. It is sectioned for a better view. No holes has been cut here. So now afterwards you move it forward to the next station. Here you use the bypass cam on the flange which you have already cut, and do the trimming and the piercing from the opposite side. So this is how, so this is what it is. Cam pierce off the back side, and again you take it forward, you cut off this bridge here, and finally you got the part. All right, so let us just have a general look at the die. This is the bottom half. You'll see a trigger here, finger. You see the die here, and this is the bending. This is the heel block, which will support the bending punches, and the punches bending the part. It will stop it from yielding. So this is the heel block. Heel block. And again, you move it forward, move the strip forward. So this is what we have been discussing in the last few slides back. You use the bypass cam from this side and then punch the hole and the slot. Leave an idle station here. Again, move it forward, and the bypass cam will go on to the other side. Another bypass cam will be arranged from this side to support the flange which is already been cut, and pierce from the opposite. And finally, this is the cut-off die profile, and the part will fall down. So you can see the strip overlaid. It's in red here. See? So this is how generally it is going to look. And for each cam, you can observe there is the heel block to support the driver from yielding back. It's on both sides. One for the bypass cam, and the other one for the trim cam. So an isometric view will give you a better comprehension. So this is how it is. It's a bottom plate. The parallels are mounted to attain the right height and the die height. And here you will see the die profile here. And this is the bypass cam, and this is the pierce cam. And again, the bypass cam will come on to the opposite side, and you will see the pierce cam on the opposite flange in the other station. So now you can see the bumper blocks being mounted here. So this will act also as a die protection, and it is in the press. So these are the bumper blocks or stopper blocks or whatever you call it. You have 4 of them and 4 corners. Four of them, 4 corners here. So this pillar has been removed just for clarity, and you can see the part overlaid. This is where the bending takes place. This is where it attains the shape. And this is where the slots are cut to the right position after bending. Closer look at the piercing arrangement here, and also pay attention to the arrangement done to keep the slide, move the slide in and out. You have made a channel in which it can, a track in which it can slide in and out, and of course it should be a sliding fit so that the clearance between the punch and the die will be constant all the time. And this is the top portion. So this will be the profile cutting, the cutting punches, which will cut the shape. Here's punches, here's pallets, and these are the gas springs, nitrogen springs. And you need to understand how the stripper is been designed. You can see 4 blocks here. Use a different color here. Use this. Take a look here. There is a square shaped block. And you have 4 of it, 4 corners. This one is here. The second one is here. The third one. And the fourth one. Fourth one. And these are the drivers. Uh, so the drivers, of course, this is the taller one, which is the driver for the bypass cam. We already have understood and we have discussed why it should be taller than the its counterpart, which is the um, pierce cam driver. You can see it on the opposite side. So right from this picture, you can understand this is taller than the pierce cam driver. So the bypass cam driver can be painted as blue. So this is, since this is taller, it's going to engage the bypass cam earlier than the PS cam driver can even um, get to rub on the cam itself, right? Closer look. This is the getting punches. The profile. And this is where you need to maintain some extra material for shaving it on a later operation. just have a look at these holes here. We'll come back and discuss what this is about. See some holes here. It's on all the punches and pilot. I'll come back and explain to you what that is. And this is what the stripper is. See? And you observe this slot here. See the slot? And this is the width which is going to slide in the support block, which we have painted in green earlier. So it is going to slide. So basically this width here should be same as the width here, which is painted in yellow. So it's going to slide on those 4 posts. So the stripper, the red line here, it is dropped down now. And as I said, this is a slide fit here. This U shape on 4 guides. So it's not going to wobble around. Now what you need to do is you have to stop it from coming up. So you need to put a cover plate. You have to put a cover plate. You can see the stripper is dropped down now. But in the same way you can move it up, right? Because nothing is stopping it from coming up. So you need to put a plate here that you can see from in the next drawing. So this is the plate. See, it's a keeper plate or cover plate. So it will prevent it from moving up or dropping down if it is flipped over, right? See the 4 keeper plates here. The 4 keeper plates will do the job, and finally your die is done. And see the pilots here, we have chosen to mount it on the stripper because there is no much room in the bending station. So these pilots stay on the stripper and rest are mounted from the punch holders. So you can watch here, the strip is being laid over, and you need to build a chute so that the part can fall smoothly. Otherwise, if you don't do that, take a look here, it is a little far away. See this portion here? So it might drop here and it will not fall off, right? For that reason, you need to build a chute. This is a chute here. So it can slide and then fall out of the tank. And just like you have put a keeper plate for the stripper so that the stripper will not move up, you need to provide the same keeper plate or cover plate for the cam also, otherwise the cam can lift up, right? So that's what you see in this. And designers usually go and install a sensor here as a usual practice in the industry. So we'll put a sensor here, and it will be wired to the machine, and when this moves in and out, it will signal the press whether to cycle or not. Just in case if this is not in position, the sensor will not trigger the press, so it will be safety. It's just for the safety purpose. Because just in case if the strip is not in the right position, you might lose some punches if the press cycles and try to the pilots will land in a place where there are no holes. You can just imagine what's going to happen. So the general practice is to have a safety sensor at the trigger stop here. So this is pretty much it is, and this is what that gas spring is all about. This is how it looks like, and it comes in different shapes and sizes, different pressures, and you choose according to the catalog, according to your requirement. And I just asked you to earlier. I asked you to just pay attention to these holes here, which is staying just beside the punches here, right? So this is what it is. It's a ball lock punch. So if you put a pin here and try to push it down, there's a ball which is in line with the axis of the against the axis of the punch or the pilot. So what you do is if you put a small pin, maybe diameter 3 or 4, and then push it down. So you push it down, so the ball will move away from the axis, so you can pull the punch out. And why it is why we have chosen such a arrangement is just in case for silly little chip off of the punch, you don't need to bother taking the whole the die out of the press, taking to the shop, open it, then remove the punch holder, remove the punch, and put a shoulder punch back. All you can get away with all those difficult things in press working. So and also you can fight the downtime. So the moment you have to remove the die from the press, your downtime clock is going to tick, right? So in order to avoid that, it's a quick method. It will save you some enough time, not some time. It will save you enough time. Um, so even say if it is the pilot, you put a pin in this small hole, push it down, and pull the pilot out. And same way you just drop it back. It will click to position, and it is and where the ball is going to click, it is going to click in this teardrop. See that ball, and it will be a spring-loaded ball, and it's at an angle. So what you are going to do is put a pin through that small hole and push the ball away from the axis of the punch, so this can be pulled out. And what you see is different shapes here. This is a cutting punch, this is a pilot, and it's another notch punch. It comes in different shapes and sizes, or sometimes you buy it standard and cut it to the size what you need. That's another thing which you need to observe is how to bring the cam or the bypass cam or the pierce cam back. So the driver will be pushing along this angle when it's flipped down, right? And it will ensure the moment forward, and that's the moment in which it is going to pierce the part. But what is going to bring this cam back when the driver goes back, right? So this little this gas spring here, which is mounted inside the U channel, so it will be pushing against this post here. See, just imagine when it is flipped upside down, right? So when the cam moves forward, so it will this piston like thing will be pushed inside, and it will be under pressure. And when the cam goes back up, this is going to push this post, and eventually this cam is going to go back to its original position. Uh, so let us quickly just go ahead and see the all the learnings what you already comprehended in the past many slides. Let us see the question number 1: reason for not designing the pierce and trim profile before the bending is taken place, right? So it is just because it is difficult to maintain the position of the trim. It's to maintain the position of the trim line and the pierce slot because it is tolerated to closer numbers. In a general, in an open tolerance, you can go ahead and design the way which you have seen in the first slide. You can bend, drill it, or I mean, not drill. You can pierce it and finish the trim line before you bend on an open tolerance part, but the part which we discussed is tolerated to very close numbers. So don't attempt to finish the profile and the pierce before it is bent. So question number 2, reason why the slots and trims are not punched in the same stage. So this we discussed in a few slides after the first one, because the horn is not thick enough, right? So you have slug will get accommodated, get clogged inside the die, because it will not have enough room to fall, and finally the die will burst. And another question here, reason why there should be a support from the back side of the horn when the cam punches apart. So we already discussed on this. If you leave the other side open when the part is being punched from the opposite side, nothing is going to support the back side, right? So the horn is going to it will have a lateral thrust, and finally the screw that is holding the horn will break, and it can create enough damage to the die and the punch. And question number 4, how is the trimming of bypass cam and PS cam controlled? There's a timing issue here which we discussed in detail. So you want the bypass cam driver uh, uh, to come fast, to move ahead, move forward before the PS cam even comes closer to the sheet. So what you do is you just design the bypass cam driver longer than the uh, PS cam driver. And just one more question, how is the movement of bypass cam stalled once it reaches the horn? So the question is actually like you want the bypass cam to come operate earlier than the PS cam, but what will happen to the bypass cam after it touches the horn or on the part? It should not move forward, right? So the arrangement is one, even though the bypass cam driver is longer, the engagement angle is cut to a very small length, and that length is maintained just enough for the cam to move forward and just stay behind the other flange, opposite side flange. And further movement, once the cut portion, the angular portion passes the supplement angle of the bypass cam, it's the straight portion which is going to rub at the tail, and it's not going to create any lateral movement. So this is how it is being controlled. So this is all about this advanced multi-stage tooling depicted with a simple example. Hope you understood the concept, the reasons, um, like wish you practice with some of this kind of components. And when you do, just have enough sections which will expose the bypass cam and the trim cam, and also section throughout laterally, so it can show the general stages of, or generally all the stages of the tool. So wish you all the best. Hope you have comprehended this chapter. Wish to see you soon on more of these kind of videos on later date. Thank you.